Hello everyone. Today let us look at reduction formula. What do we mean by reduction formula? So reduction formula, you are basically given angles that you will reduce into special angles. But you don't just reduce. You reduce using what? You reduce using rules, right? So remember that our special angles, let me just maybe I will say special angles. So our special angles, right, are within the following, right? So you've got 0 degrees, you've got 30 degrees, you've got 45 degrees, you've got 60 degrees, you've got 90 degrees, and then you've got 180 degrees, you've got 270 degrees, and you've got 360 degrees, right? So these are our special angles. However, there are angles that you can use special triangles to get what? To get their definitions. If you've got a trig ratio assigned to one of these special angles, you can use their trig ratios. You can use the special triangles, right? But in this case, we are looking at 0, 90, 180, 270, and 360. But how do you get those, right? So you get this from, let's say we draw this Cartesian plane here. So this is what you're going to be playing around, okay? So this Cartesian plane, let's label it, this will be 0 degrees, that will be 90 degrees, that will be 180 degrees, that will be 270, and then back to 360 degrees, right? So what reduction formula does is you will be given angles and you need to be able to reduce this angle into special angles. And when you reduce into special angles, it's gonna be, if we find that it's an acute angle, so acute angle will be actually be defined by 90 degrees minus theta. Let's say you've got whatever angle you have, so you are saying 90 minus a certain angle, which might be also a special angle, but depending on the case, right? So, but if your angle is between 90 degrees and 80 degrees, so you will need to reduce this into the so-called 90 degrees plus theta, or 180 degrees minus theta. Because yes, anything here, it's either it's 90 plus or 180 minus that angle, right? Given that your angle theta, it's an acute angle, right? And then if your angle lies within the third quadrant, here it's going to be, you reduce it to 180 plus theta, right? Or 270 degrees minus theta. If your angle lies within this range, it's going to be 270 plus theta, or 360 minus theta, right? So you will be given angles that you are going to reduce into 90, 180, 270, and 360. Why? Because we can simply define trig ratios of special angles, right? For example, right, let's say we say, okay, use reduction formula, okay, to locate where the angle theta, right, I will say where the angle theta is, right? So here we're trying to determine what the quadrant. Okay, we'll say quadrant, right? So what we have here, right, let's say I will remind you the arguments that we have. So the arguments that we have, we've got 90 degrees plus or minus theta. And then we've got 180 degrees plus or minus theta. We've got 270 degrees plus or minus theta. And we've got 360 degrees plus or minus theta, right? So these are called what? They are called arguments, right? They are called what? Arguments. And how do we express arguments? So arguments cannot go alone, but they are used with trig ratios, right? I will say trig ratios can be expressed in terms of theta. As long as you have any of these arguments, you can then be able to express any trig ratio in terms of theta. So that will depend on where the trig ratio is at, right? So that lead me to the next diagram, right? So the next diagram we're gonna be looking at, let's say the next diagram, I'm gonna be looking at the polarity, right? So the polarity of trig ratios. Okay, I'm gonna be looking at the polarity of trig ratios. Okay, polarity of trig ratios. So the polarity of trig ratios, the way it works is, here we've got the first quadrant, right? We've got all trig ratios that are positive. In the second quadrant, we've got only sine, which is positive. In the third quadrant, only tan is positive. In the fourth quadrant, only cos is positive. And then you'll be able to then play around with these values. Okay, for instance, we are going to reduce, for now focusing on this scale, right? For this exercise, let's just look at just the horizontal scale, right? The horizontal line. Okay, horizontal line, right? Meaning that we're going to use 0 and 180. Okay, so when we use 0 and 180 and you need to reduce, or you need to find, we need to express all trig ratios in terms of theta. What do we do here? So what we're gonna do is, let's say we are given what? We are given a sine of, let's say we are given sine of k0, 0 degrees plus theta, right? So this is what you're gonna do. You will look at 0 plus. 0 plus, it's basically in the first quadrant, right? So for instance, I'm going to copy this, right? I will copy this diagram, copy, and then paste it here, right? So that we can see what we're actually referring to or talking about, right? Paste it here, right? So when we look at 0 plus, it's basically here, 0 plus theta. But in the first quadrant, sine is what? Sine is positive. So this is going to be reduced to sine theta. So this is what we are basically talking about, right? When we look at cos 0 degrees plus theta, right? So this will be reduced to, again, 0 plus. Everything in the first quadrant, it's basically positive. Even when we go for tan, so tan of 0 degrees plus theta will give us plus tan theta, right? But the issue changes when we go to, let's look at 180. If we look at sine of 180, let's look at 180 minus, right? So 180 minus, we already know that 180 minus is in the second quadrant. And in the second quadrant, sine is positive. So this is going to be positive sine theta, right? And then when we look at cos of 180 minus theta, what is 180 minus in the second quadrant? Cos is negative. So this is going to be cos theta minus cos theta. If we look at tan of 180 minus theta, so this is going to give us what? because tan is negative here, so this is going to be minus tan theta, right? Yes, so in a case where we are looking at 180 plus, right, I'm just going to copy this, right, copy and then paste it here, right? So what happens here is I'm just going to add plus plus plus, right, and then I'm going to change the signs. 180 plus is in the third quadrant. In the third quadrant, sign is negative. 180 plus third quadrant cos is negative. Third quadrant tan is positive. So this is how we are going to use the reduction angle to reduce our trig ratios. Okay, I will say example. Okay, I will say here example. Let us reduce or we need to simplify tan 108 degrees minus theta times sine 180 degrees plus theta, right? So this in our second step is we are going to apply the triangle or the diagram we have seen here, right? So 180 minus is in the second quadrant, and in the second quadrant tan is negative, so this is going to be negative tan theta times 108 plus is in the third quadrant. In the third quadrant again sine is negative, so this would be negative sine theta, right? But we know that tan is the same as sine theta over cos theta times what? Sine theta. Don't worry, the negative can cancel, right? So what do we have here? So here we're going to have, okay, sine squared theta over cos theta. So this is when we have reduced it. This is how we apply reduction angles or the reduction formulas.